Today, we're jumping into a tool called AIPerf. It's becoming absolutely essential for anyone working with generative AI. And we're going to see exactly why, because a truly brilliant AI model is pretty much useless if it can't perform under pressure. So, you've spent all this time, all this energy, training or fine-tuning an amazing AI model. It's a genius. It writes poetry, it generates code, it can answer the most complex questions you throw at it. But here's the real question, the million-dollar question. When actual users start hammering it with requests, is it fast? Is it reliable? Because in the real world, brilliance without performance, well, it's just a traffic jam.
All right, so here's our game plan for today. We're going to start by laying out this whole performance puzzle, then introduce AIPerf as the piece that solves it. We'll get into the nitty-gritty of how it mimics real-world chaos, look at the metrics that actually matter, figure out what to do with the results, and then wrap it all up with why this kind of benchmarking is just so critical right now.
Okay, let's kick things off by really setting the stage. Let's talk about the core challenge here, the AI performance puzzle. I mean, think about it for a second. A slow chatbot is just frustrating. A service that completely falls over the second it gets popular is useless. And an AI solution that costs an absolute fortune to run simply isn't sustainable. So things like speed, reliability, and cost, these aren't just nice-to-haves. No way. They are absolutely mission critical if you want any AI application to actually succeed. That's the puzzle every single developer is trying to solve.
So how do we start to put the pieces of that puzzle together? Well, that brings us right to our main event, AIPerf.
To put it simply, AIPerf is basically a specialized tool that's built to stress test your AI. Think of it like a giant virtual crowd of users all hitting your model at once, so you can measure exactly how it holds up under a ton of pressure. And the great thing is, it's designed to work with pretty much whatever inference solution you're already using, which makes it incredibly flexible. And this thing is packed with features. It's totally scalable, so you can simulate massive amounts of traffic. It's got a modular design, so you can tweak and customize it. It has different UIs depending on what you need. And it supports a whole bunch of common datasets and APIs right out of the box. Now here's where it gets really cool. This tool goes way beyond just simple tests. It is designed from the ground up to simulate the messy, totally unpredictable nature of the real world. So check this out. AIPerf doesn't just spam your server. It can simulate different arrival patterns, kind of like the random bursts of traffic you see in real life. It has fine-grained controls for stuff like prefill concurrency, which is super important for avoiding memory meltdowns with those really, really long prompts. It can also ramp up the load gradually to find the exact breaking point of your server. It can even simulate users just giving up and canceling their requests so you can test how resilient your system is. It also lets you get super specific with your own data. For example, trace benchmarking lets you replay an exact sequence of requests right from a log file. This is amazing for A/B testing two different models, or for checking if a new software update accidentally slowed things down. You can also test with your own specific prompts, or even benchmark custom APIs. So the key takeaway here is you're not just testing some generic model, you're testing your model with your actual workload. Okay, so we've simulated the real world, we've thrown a ton of traffic at our server. What now? What do we actually measure? Let's dive into the metrics and see what really matters. AIPerf collects a mountain of data, but it organizes it into these nice categories. You've got streaming metrics that tell you about real-time responsiveness, token-based metrics for raw speed, and even low-level HTTP stuff for debugging network headaches. But let's zoom in on a couple of the ones that are probably the most important. First up, we have time to first token, or TTFT for short, and it is exactly what it sounds like. How long does a user have to wait after they hit send before the very first word starts appearing on their screen? And this is just so critical for user experience, right? A low TTFT, we're talking just a few milliseconds, makes an AI feel snappy, responsive, almost alive. But a high TTFT, well, that just feels like lag. It makes the whole system feel sluggish and broken, even if the rest of the answer generates super fast. It's all about that perceived performance. Next up is this fantastic concept called goodput. Now, this isn't just plain old throughput, which is just the total number of requests your server handled. No, goodput is the number of requests that were handled well, meaning they met the performance targets you actually care about, like responding in under 2 seconds. It cleverly filters out all the slow or failed requests to give you a true measure of your useful capacity. All right, now for the payoff.
how do we take all of this rich data and turn it into decisions we can actually act on? Let's take a look at the final report.
Now, this table might look a little intense at first, but it's telling a really clear story. We can see our average time to first token is about 18 milliseconds, which is incredibly fast. We can see the overall request latency and the inter-token latency, which tells us how quickly the rest of the tokens are generated. But I want to draw your attention to one number here in particular. That one, 10,944 tokens per second. That is the output token throughput. So what does that actually mean? Well, this number, it represents the total fire hose of text your entire system can pump out every single second while it's under a heavy load. This is an absolutely critical number for capacity planning. It helps you answer questions like, how many GPUs do I need to buy? Or can my current setup handle a massive traffic spike? This one metric directly connects technical performance to your budget and your infrastructure.
So let's zoom out one last time and put this all together. Why would you go through all this trouble? What's the real strategic value of doing this kind of in-depth performance testing?
Well, the benefits are huge. You can actually validate the promises you make to your users and make sure your service is reliable. You can make objective, data-driven decisions when you're comparing different models or deployment options. You can fine-tune your infrastructure to squeeze every last drop of performance out of it, which saves you money. And maybe most importantly, you can catch slowdowns before they ever reach your users. And all of that lets you build better, faster, and more reliable AI products.
I think this quote just nails it. The whole point isn't to just fill up a spreadsheet with a bunch of numbers. The goal is to get real, concrete answers to the questions that matter, so you can make your AI better.
And that really leaves us with a final thought to chew on. As AI gets woven into the fabric of basically every product we use, the bar for performance is only going to get higher and higher. The question is no longer just, what can my AI do? The real question now is, how well can it do it when the pressure is on?